Okay, in our last class we stopped at finding the q1 value and the q2 value. The q1 value and the q2 value. So now we can also find the Lagrange. That's to impute your q1 and q2 either in equation 1 or equation 2. Well, that's something I'm leaving out for you. So we have the next step in this. The next step. Hope you're ready. Sorry. Okay, so we have the next step, and the next step is to do the second order derivation. Second order derivation, the second order. We've already done the first order condition. This is the second order condition, SOC actually. So to do this, we have the Haitian. What we have as the Haitian. This is how it looks. The Haitian. We are going to use this, and note our 1 here is represented as Q1, whereas our 2 is represented as Q2, while our lambda is still lambda. Did I write 3? It's meant to be lambda, sorry. Okay, so let's get to it. We have to bring our equation. We have to solve everything. It's gonna be pretty long. F1, F2, F lambda, F1 lambda, F2 lambda, but I'm not doing everything for you. So you can test your brain and be sure that you got the answers correctly. So okay, let's start with F11. F11. So the thing is that we're going to bring the first order derivative of Q1, and we're going to derive it again with respect to what? Q1. So our first order, this was 1.5. Now let's write it down. Let me write it well. Change in the v is same in the v. The Q1 is equals to 1.5 Q1 raised to power 0.5 Q2 equals to lambda. Let's just do the number with minus 3 lambda. So I'm going to derive this second order derivation. This is where I mark my own. I put this sign here to show that it's the second order. So when we derive this again, we're going to be getting 0.5 times 1.5 give us 7.5. 0.75 Q1, then 0.5 minus 1 will give us minus 0.5. Then we have Q2. This is out because there's no Q1 here, so this is the second order derivative for this. Have you seen it? So in this one now we have to impute what we got as our Q1 and Q2 in this equation, where our Q1 is 20 and our Q2 is 10. So when we impute everything here, we'll have our answer as 2. When you solve everything and impute and R and multiply, we have our answer as 2. So in this, we've gotten the first one, 2. So the next one is F12. Okay, so in this one we're going to get the first order derivative, the first order condition of Q1, and derive it again with respect to what? Q2. Remember I said your 2 is what? Q2. So we have the V, the Q1, which was equals to 1.5. This is the first order on Q1, 0.5 minus 3 lambda. So we're going to derive this with respect to Q2 because we have to here Q2. Okay, so when we do that, sorry, our Q2 is here. Okay, Q1 times this, we have 1.5. 1 minus 1 is 0, so it's out. So we have Q 0.5. This one is also out. So this is what we have in our second order derivative, and this is our what? Q1, right? So when we impute what we have as our Q1 is 20. Our answer would be 7. 20 raised to power 0.5, you get your answer. The answer times 1.5. It's actually a decimal point, but if you approximate it to give you 6.7, or if you approximate it, you have 7, and you now put it in that your box, your Haitian determinant box. We have 7, so you can do the rest by yourself. And note, when you see 1 and 2 is the same thing with 2 and 1. What else? Lambda and 1 is the same thing with 1 and lambda. So I already have my answers here. So we have 7 here, we have minus 3 here, we have 4, minus 4, we have 0, we have minus 3, minus 4, and 0. Okay, some people might be confused on, I'm really confused, how did you just get all these answers at once? Okay, let me just do this last one for you. This f lambda 2, f lambda 2. Okay, let's do that. F lambda 2, f lambda 2, f lambda and 2. So we are differentiating the first order of this lambda with respect to Q2. Respect to what? Q2. So we have dv d lambda. What did we get in our first derivation of our lambda? I can't remember actually. What did we? Okay, I can remember what we got. We got 100 minus 3q1 minus 4 q2. Am I right? I hope I'm correct. Hopefully. Okay, so this is what we have. Then the second derivative dv dq2 derivatives. So I think q2 here, nope, 0. Nope, 0. So here's where we have q2. So we're derivating this, and when we do that, we'll have minus 4. Minus 4. So what do we have up there in f lambda 2? F lambda 2. See? Minus 4, and it's the same. Minus 4, and it's the same with this one. I see. It's the same actually. So the next thing we have to do, remember the rule of the Haitian determinant. The rule states that, let's read the rule. If h is greater than 0, that consumer will maximize its utility. But if it's not h is greater than 0, he won't maximize his utility. So for us to solve that, we have to use this and find the determinants. This is a matrix actually. This is a matrix, and we're going to get the determinant. If you can remember how you always get your determinant. So let's get to it. Down. I hope you're having fun. Well, I am. So let's get to it. We're gonna get the determinants. Let me rewrite everything. Okay, so for the first one, we have, remember, here's to be plus, minus, and plus. This is how it works. So for the first one, we have to, it goes like this actually. For the first one, we're going to use these 2 parts, the 7 parts and the 3 parts. Okay, let's start. 0 times 0 is 0, minus 4 times minus 4 is 16. What do we have up here? Minus number 7. So it's just as if from the row and the column of 7 you're going to block it. So the row and column of 7 is blocked. So what do we have left? We have 7 and 0. 7 times 0 is 0, minus 3 times 4, minus 3 times minus 4 is 12. What do we have up here? Plus. But what do we have here? Plus times minus is what? Minus. And what number? 3. We block the row and the column of 3. The row and the column. This is the column. The column is like a pillar and the row is this way. Row, column. Okay. So when we block it, we have 7, 4, and 0 and 3 remaining. 7 times minus 4 will give you minus 28. Minus 3 times 0 is 0. Close your bracket. Okay, if you expand all this and solve, should we do it? I don't think we should, but let's just do it for doing sake so no one gets confused. 0 minus 16 minus 16, minus 12, minus 3, minus 28, So this is what we have here. If you multiply minus 32 plus 84, right? Oh, I'm just mixing everything up. Yes, plus 84 again. So when you add all this together, we have 136. So this is our Haitian determinant. So is 136 greater than 0? Yes. So let's read the last part. Okay, this is it. This is the explanation of everything. Since the relevant bordered Haitian determinant H is equals to 136 and it's greater than 0, it implies that the values Q1, the values of Q1 and Q2, that's 20 and 10, that the consumer maximize is his maximum utility. So he can use the Q1 and Q2 to maximize maximum utility because this has determined everything. Well, I hope you understood this Lagrange multiplier problem that we just did. And if you have a question or if you have questions, please do not lose out on knowledge. Knowledge is power, actually. So don't to chat me up on the comment section. I would be willing to help. I'm very willing.